Welcome back to our channel. Climate models are powerful tools that scientists use to understand and predict changes in our climate. These models simulate the interactions between the atmosphere, oceans, land surface, and ice. Let's break down how they work. Part 1. How climate models work. At the core of climate models are mathematical equations that represent physical processes. These equations describe how energy and matter move through the Earth's system. For example, they can simulate how sunlight heats the Earth's surface, how heat is distributed by the atmosphere and oceans, and how water evaporates and forms clouds. There are different types of climate models, including general circulation models, GCMs, and Earth system models, ESMs. GCMs focus on the physical climate system, while ESMs include additional components like the carbon cycle and vegetation. These models divide the Earth into a grid, with each cell representing a small area of the planet. The smaller the grid cells, the more detailed the model, but this also requires more computational power. Supercomputers play a critical role in running these complex models. They perform billions of calculations per second to simulate the Earth's climate over decades or even centuries. The output includes temperature, precipitation, wind patterns, and many other variables. Predictions for future climate scenarios. Now, let's talk about the predictions these models provide. Climate models generate scenarios based on different assumptions about future greenhouse gas emissions, land use, and technological development. These scenarios are known as representative concentration pathways, or RCPs. RCPs range from low-emission scenarios, where greenhouse gas concentrations stabilize or decline, to high-emission scenarios, where concentrations continue to rise rapidly. For example, RCP 2.6 represents a low-emission scenario with ambitious mitigation efforts, while RCP 8.5 represents a high-emission scenario with little mitigation. Using these scenarios, climate models predict various outcomes, such as global temperature increases, changes in precipitation patterns, sea level rise, and the frequency and intensity of extreme weather events. These predictions help scientists and policymakers understand the potential impacts of different emission pathways and inform strategies to mitigate and adapt to climate change. For instance, under high-emission scenarios, we could see significant sea level rise due to melting ice sheets and thermal expansion of seawater. This would threaten coastal communities around the world. Similarly, increased temperatures could lead to more frequent and severe heat waves, impacting public health and agriculture. Part 3. Importance of accurate modeling. Accurate climate modeling is essential for several reasons. First, it provides a scientific basis for understanding climate change and its potential impacts. Without accurate models, our ability to predict future conditions and plan for them would be severely limited. Second, accurate models help policymakers make informed decisions. They can evaluate the effectiveness of different mitigation and adaptation strategies and allocate resources where they are most needed. For example, climate models can inform the design of flood defenses, agricultural practices, and public health measures. Finally, accurate climate models are crucial for global cooperation. Climate change is a global issue, and addressing it requires coordinated efforts from countries around the world. By providing a common understanding of the risks and potential solutions, climate models facilitate international agreements and collaborations. In conclusion, climate models are indispensable tools for understanding and predicting climate change. They help us prepare for the future by providing insights into the potential impacts of our actions. By improving the accuracy of these models, we can better protect our planet and ensure a sustainable future for generations to come. Thanks for watching. If you found this video informative, don't forget to like, share, and subscribe to our channel for more deep dives into the science of climate change. See you next time.